All right, guys, skipping the do now, going right in. So we are talking about transformations. Transformation is a function that changes the position. Ooh, that is a little, yeah. Shape and or size of a figure. The inputs for the function are points in the plane. The outputs are other points in the plane. A figure that is used as the input of a transformation is the pre-image. The output is the image. Okay, so whatever you start off with is the pre-image. Whatever you end up with is called the image. And a transformation can change its location. It can change its size. So like a dilation is a transformation because we change the size in a dilation. So you can change its position. You can change its size. You can change its shape. All those fall under transformations. For example, the transformation T moves from point A to point A prime. Do you all see that little slash on top of the A? That's called prime. And anytime we have a transformation, usually after the transformation occurs, whatever the new point is, you put that sort of slash on top of it and use the same variable to represent it. So A moves to A prime. Point A is the initial one that we have, so that's called the pre-image. And A prime is the image. So whatever you start off with is the pre-image, whatever you end up with is the image. Hey, sometimes a transformation is called a mapping. So transformation T maps point A to point A prime. All right, so there's two different kinds of notation when we're talking about transformation. There's something called coordinate notation. And coordinate notation uses parentheses. So what this means, look down here where I'm highlighting in pink. This XY arrow yields x plus 2 comma y minus 3. This is called coordinate notation where you use the parentheses. And what this is telling us is we take whatever our pre-image is, that point, x comma y. And then for every xy, what we're going to do is we're going to add 2 to the x coordinate and we're going to subtract 3 from the y coordinate. But if we're on the graph, right, if I'm adding 2 to the x coordinate, I'm taking that point and I'm moving 2 units where? If I'm adding 2 to the x. I'm moving left, right, up, down. What do you think that means on a graph? For x?
Oh, for x.
Left to the negative side, if it's plus 2. To the right, right, because it's positive. So we're going to take our initial point, then we're going to take that point, move it 2 units to the right, and then 3 units, where do you think? Up or down? But it's a minus, so down. So we're moving 2 to the right and 3 down. That's coordinate notation. So if we were using this notation, if I had my pre-image point as 6, 5, where would I end up? Well, that's saying we know this is x comma y, so we're going to take 6, 5, and we're going to add 2 to the x coordinate, and we're going to subtract 3 from the y coordinate. So our image is going to end up becoming 8, 2. So our new point is 8, 2. Okay, so the way we read this is T of E equals F. And what this is telling us is I have T as our transformation. And we are performing the transformation on E, and then the result is F. So T is our transformation. We're performing the transformation on what? We're performing the transformation on E. What's our result? F. So now I'm asking you, in this, what do you think is the pre-image? What do you think is the image? Out of all these variables, we have T, we have E, we have F. Which one do you think is the pre-image? Simon. E. You got it. Our pre-image is what we initially start with. So our pre-image is E. What do you think our image is going to be? You got it, Sam. F. Okay, consider the transformation given by the rule xy yields x plus 1, y plus 1. Describe the transformation. When I ask you to describe the transformation, I want you to tell me how would this look on the graph. If I had any random point and I did this transformation on this random point, where would this point move? X plus 1, y plus 1. 1 unit where and 1 unit where? Good. Every point we have, wouldn't we move it 1 unit to the right because it's x plus 1, and then 1 unit up because it's y plus 1? So consider the transformation, describe the transformation. So we would say the pre-image would shift 1 unit to the right and 1 unit up. Okay. So now let's perform a bunch of these transformations. So for the first one, it's a nice easy shift. I'm just going to highlight our coordinates of these triangles. I have the point 0, 4. I have the point 2, 0, and the other last point is 0, 0. And now what is it telling us to do to each of these points? Can somebody explain this transformation for us? What is it asking us to do? Move where and where? You got it. 4 units to the left, 3 units up. So what we're going to do is we're going to take each point and move it 4 units to the left and 3 units up. So here we are. Let's go with blue. So I'm going to go 1, 2, 3, 4, and then 1, 2. Let's say this is A. This is now my A prime. The prime, the slash on top, is always our image after the transformation. That little slash on top. All right, next one. We're at 0, 0. So now I'm going to take that point. I'm going to move 4 units to the left. 1, 2, 3, 4, and then 3 units up. 1, 2, 3. We'll call the pre-image B and the image B prime. All right, then the last one, which is the point 2, 0, I am going to move that 4 units to the left. 1, 2, 3, 4, and 3 units up. 1, 2, 3. Call that C and then C prime. And then we have to connect the dots. Oh, that A prime, I didn't move it up enough. Do you guys pick up on that?
Yeah.
The A prime, I only went 2 up instead of 3 up. 1, 2, 3. 1, 2, 3, 4. There we go. Now that looks better. Yes? Sure. Give me 1 second. That better?
I'm good now, thank you.
Okay, so what's happened from our pre-image to our image? Did I make it bigger or smaller? Did I change the size at all?
No.
No, all I did was shift it, right? All I did was shift it to a different location, but it's still the same exact triangle, just shifted to a different location. All right, now what is this saying? This is saying the rule is saying take XY, switch the XY coordinates, and then negate the Y coordinate. All right, so for this one, I want to list out my points. That's going to be the easiest way to do this. So A, we'll say, is the point 0, 4. B is the point 0, 0. And C is the point 2, 0. So now we have to perform the transformation. So the transformation says negate the Y coordinate and flip its position, switch it with X. What does that mean? That means my A prime, I'm taking my Y coordinate from my A, from my pre-image. What's my Y coordinate in my pre-image? 0 or 4? 4. I'm negating it. When I say negate it means make it the opposite. It doesn't mean make it negative. It means make it the opposite sign. So if it's positive, make it negative. But if it's negative, make it positive. So you're negating it, not just making it negative. You're making it its opposite. So it's saying negate the 4. So how do I negate a positive 4? It becomes negative 4. But then put it in the X spot. Yep, you flip them. And then put the X in the Y spot. So now this A prime is going to be the point negative 4, 0, which is right over here. So now we're going to perform the same thing, same rule, but on B, which is 0, 0. Can I negate a 0?
No.
Is there such a thing as a negative 0?
No.
No. And then when I switch it,
It's still 0.
It's just 0, 0. So the origin stays at the origin. It's right here.
I don't think this graph is good.
It's not big enough. Why not?
Wait, is it? I'm not sure.
Yeah, we're good. Can somebody tell me what to do with C?
Flip the 2 and make it negative.
Good. We're not going to make the 2 negative, right? We're going to take the Y coordinate, which is 0. Can I make 0 negative? No, I can't make 0 negative. So it becomes 0 and then put the 2 in the Y spot. So we're now at 0, 2, which is right over here. What do you think happened to this?
It rotated.
It rotated. You're right. It rotated. So the first one shifted. The second one just rotated. So it was standing straight. We rotated it onto its back, right? Now let's see what happens when it says XY yields X half Y. What do you think that rule means when it says X half Y? Well, X, are we doing anything to the X coordinate? No, so it means keep the X coordinate the same. What do you think half Y means? Take the Y coordinate and do what to it? Divide it by 2. We're going to divide it by 2. So let's go ahead and do this. We know our A is 0, 4. And now we want to perform our transformation. So our A prime is going to keep the X the same. So what am I keeping the same? Which number? 0 or 4? Which number am I keeping the same if it says keep X the same?
We're just going to make it 0.
Yeah, we keep it just 0. But then it says take half of Y. Well, what's half of 4? 2. So now our A prime is going to be the point 0, 2. All right, now let's look at B. B is 0, 0. So B prime says keep the X coordinate the same. Well, my X coordinate is 0, so I'm keeping that the same. Then it says take half the Y coordinate. But what's 0 divided by 2?
0.
Still 0. So the origin just stays at the origin. And then the last one is 2, 0. So for 2, 0, it says keep the x-coordinate the same. Well, the x-coordinate is 2. And then it says take half the y-coordinate. But half of 0 is 0. What happened to this triangle? It what?
It shrank.
Yeah, it got smaller. Okay, so now we're using the above A, B, and C to answer these questions. A transformation preserves distance if the distance between any 2 points of the pre-image is equal to the distance between the corresponding points of the image. Which of the above transformations preserve image? All right, let me explain to you what that means. It's considered to preserve image is if your pre-image and your image are the same, are congruent. So you tell me, out of A, B, and C, which, if any, preserve distance, meaning your pre-image and your image are congruent? A and B, very good, Simon. A and B preserve distance, meaning your pre-image and your image are congruent. A transformation preserves the angle measure if the measures of any angle of the pre-image equals the measures of the corresponding angles of the image. Which of the above transformations preserve the angle measures? Only one does not preserve the angle measure. Which one does not preserve the angle measure? C. Why does C not preserve the angle measure? Because we know the right angle by the origin is still a right angle by the origin. Do we agree with that? But everybody look at the point 2, 0. Look at the pre-image and the image. Are these the same angles? No, the image is definitely smaller because this is drawn to scale. How come this is drawn to scale? Because we're on a graph. So we know the image has a larger angle by that 2, 0 than the smaller one. So this does not preserve the angle measure. So only A and B preserve the angle measure. All right, so now we're going to have something called rigid motion. Did I see? All right, a rigid motion is a transformation that changes the position of a figure without changing the size or shape of the figure. All right, there's really only 2 main properties of rigid motion. We have to preserve distance and angle measure. So essentially speaking, in order for something to be considered a rigid motion, your pre-image and your image have to be congruent. If your pre-image and your image are congruent, then it is a rigid motion. Okay, so now we're just going to say, does this appear? We don't know for a fact. It's sort of like, does it look like it could be a rigid motion? So you tell me, does it look like it could be a rigid motion? Letter A? Absolutely. Didn't I just sort of rotate it? So yes, rigid motion. Transformation does not change the size or shape. All right, what about letter B? Rigid motion or not rigid motion? How many people say yes, rigid motion? How many people say not rigid motion? Good, this is not a rigid motion. Right here, we definitely changed the shape of this triangle, right? we had one triangle, and then the other triangle, isn't it being extended? That's C prime. So we're definitely changing the shape of this triangle. Changes the shape. Okay, so now we're going to practice drawing the image under the transformation. So for letter A, what am I asking you to do for letter A? Take x, y, and then do what to x, y? Multiply x by 3 and multiply y by 3. What do you think is going to happen to the pre-image? It will what? Become?
Bigger.
Bigger, you got it. What do we call that? When something becomes bigger or smaller?
Dilation.
A dilation, very good. So what I'm going to do is I'm going to list out all of the coordinates. So this first coordinate, let's call this A, is going to be the point 0, 1. And now let's go to B. B is -1, -1. And now let's go to C, which is 1, -1. So now let's go to our A prime. So our A prime is going to be 3 times our pre-image. So 3 times 0 is 0. 3 times 1 is 3. So now we're at 0, 1, 2, 3. B prime. Our B prime, multiply both coordinates by 3. We're at -3, -3. Can somebody tell me the coordinates for C prime? Maya? Three, 6. 3, 9. What is it? I don't know what you're saying.
Is it 3 -3?
It is 3, -3. What does the rule tell us, guys? The rule tells us is multiply the x coordinate by 3, multiply the y coordinate by 3. So our C is 1, -1. So 1 times 3 is 3. -1 times 3 is -3. Everybody okay with how to read these transformations? Yeah? Okay. So then we're 1, 2, 3, 1, 2, 3. There's our C prime. So now, do we think this is a rigid motion? Yes or no?
Yeah.
Really?
No, it's not.
No, why is it not a rigid motion? Not rigid motion.
Oh, it doesn't preserve size.
It does not preserve the size, exactly. All right, for letter B now, it's saying the rule is telling us take any x, y coordinate, keep the x the same. What do you think -y means, Oscar? What do we think -y means? Finn? Negate it, make it the opposite sign. So let's come up with our coordinates. So let's say this is A. So my A coordinate is the point -4, 1. Say this is B. B is the point 3, 1. And then let's say this is C. C is the point 1, 2, 3, up 1, 2, 3, 4. Now I want to perform this transformation. So what does the transformation tell us to do? Keep x the same and negate the y. So my A prime, keep the 4 the same and negate the 1. What is the negation of a positive 1? Negative 1. So now our point is negative 4. That should have been a negative 4. Keep the x the same. Negative 4, negative 1. There is my A prime.
What was the thing in the last one when you like switched them?
Oh, it's when it's written y and then x.
Oh,
Okay, now let's do letter B. Somebody tell me, what is letter B going to become? So the rule says, Danya? Good. It says keep your x the same, so 3 stays the same, and negate your y, so negative 1. 1, 2, 3, negative 1. There's our B prime. All right, somebody tell me with letter C. Maya. You got it. Keep our x the same and negate our y. Does anybody know what this was? No, we don't know that it's a 30, 60, 90. That's funny, though. Does anybody know what kind of transformation this is? What did we do to this image? We reflected it. We reflected it over what? Didn't we reflect it over the x-axis?
Always.
Yeah, it just created a mirror image over the x-axis.
Does algebra have any of this transformations?
Does algebra 2, you mean? No. All right, letter C and letter D. Do you think you guys can figure this out on your own? Try letter C and D on your own, and then we'll go over it. Are we ready? Let's see what we have here. Oh, sorry. Was letter B a rigid motion or not rigid motion? What do we think? Rigid motion. All right, letter C. So this transformation is telling us take every coordinate x, y, and keep your shift your x coordinate 3 units to the right, but keep your y coordinate the same. Vin? Yes. So we're going to take our first x coordinate and I'm going to shift it 3 units to the right. 1, 2, 3. Am I moving up or down at all? No. So here's my A, here's my A prime. Then I'll call this B. Going to take the point B, shift it 3 units to the right. 1, 2, 3, and then keep the y the same. So there's my B prime. And then lastly, take my C and shift it 3 units to the right. 1, 2, 3, and keep my y coordinate the same. So I'm going from A prime to B prime to C prime. I went a little bit too high here. Was this a rigid motion, yes or no? Yes. How many people got this correct? Good. All right, what is letter D telling us to do? Anybody know? What is letter D telling us to do? Negate the x coordinate and also negate the y coordinate. Am I switching them? No, we're not switching them. So what I'm going to do is I'm going to write out my coordinates. Here's A, here's B, here's C. So my A coordinate is the point 1, 2, 1, 2, 3, 4. So A is 2, 4. My B is 1, 1. And my C is 1, 2, 3, 1. So our rule is telling us negate them both. So my A prime is -2, -4. My B prime is going to be -1, -1. And my C prime is going to be -3, -1. So -2, -4. Here's my A prime. And then -1, -1. There's my B prime. And then -3, -1. There's my C prime. All right, rigid motion or not rigid motion? What did you all say? Rigid motion or not rigid motion? Rigid motion. How many people got that correct? Great. All right, moving on to reflections. One type of rigid motion is a reflection. A reflection is a transformation that moves points by flipping them over a line called the line of reflection. The figure below shows the reflection of quadrilateral ABCD across line L. Notice that the pre-image and image are mirror images of each other. So when we're dealing with reflections, you have a line of reflection. Wherever that line of reflection is, basically you're creating a mirror image on the other side of that line of reflection. All right, so some little shortcut rules. If we're reflecting over the x-axis is the horizontal axis. The rule tells us take xy, keep your x coordinate the same, but negate your y coordinate. The shortcut rule for reflection over the y-axis tells us take the point xy, negate your x coordinate, but keep your y the same. And the shortcut rule for reflection over the line y equals x. Does everybody know what the line y equals x looks like? It's a line through the origin like that. It's a reflection over that line. So for this, it's saying switch x and y coordinates. We're not negating anything. We're just switching the x and y coordinates. Are we ready to try some problems? All right. So now what I'm doing is I'm giving you the pre-image, and I want to know what's the new coordinate after a reflection over the given axis. So, or the given line. So I want to reflect this over the x-axis. So go back up. What does the rule tell us? Reflection over the x-axis. The rule tells us xy yields x negative y. So we're going to have the point 3, comma, negative 1. Now reflection over the y-axis. Remember, the rule says reflection over the y-axis. xy gives us negative xy. So if I'm negating the x, my x is negative 6. How would I negate a negative 6? What would that be? Positive 6. And then I'm keeping the y the same, so it stays negative 3. And lastly, we're taking the point 0, negative 2, and we're reflecting it over the line y equals x. So that's saying switch your x and y coordinates. So if I have the point 0, negative 2, after reflection over the line y equals x, we're going to have the point negative 2, 0. All right. So here it says you are designing a logo for a bank. The left half of the logo is shown. You will complete the logo by reflecting the figure across the y-axis. In the table, list the vertices of the left half of the logo, then use the rule for reflection across the y-axis to write the vertices of the right half of the logo. Plot the vertices of the right half of the logo, then connect the vertices to complete the logo. So I'm going to write out the vertices, but really, if I'm just reflecting this over the y-axis, aren't I just creating a mirror image on the other side? So this top point, this 0, 5, isn't it going to stay 0, 5 since it's right on the y-axis? Okay, then I have this point, which is negative 4, 1, 2. So now I'm going to create the same image on the other side. So 1, 2, 3, 4, up 2. Oh, sorry, not 4, 3, over 3. 1, 2, 3, up 2. And then I'm going on to the next one. So I'm 2 to the left. So I'm going on the same height, and now I'm going 2 to the right. And this very last point, oh, sorry, not the very last point, there's one more. We are here on the y-axis, maps it right back on the y-axis. And then we have how many? 1, 2, 3 units to the left. So we're going 1, 2, 3 units to the right. And now we have to connect. So do you see how I just created the image just by counting the boxes, not even using the rule?
Yeah.
All right, so now we have to write out all the coordinates. So we have, let's see, 0, 5. And then we have 1, 2, 3, negative 3, 2. And then I have negative 2, 0. And then I have 0, negative 2. And lastly, I have negative 3, negative 3. And the rule tells us when we're reflecting over the y-axis, we're negating the x and keeping the y the same. So our new points are going to be the points 0, 5, positive 3, 2, positive 2, 0, 0, negative 2, and 3, negative 3. All right, guys, you do the next one, and then we'll go over it. Sure. So you have to, for this one, you have to remember the rule. Could somebody just refresh our memory or scroll back up? What is the rule for reflecting over the line y equals x? Xy yields what? Who remembers the rule? Mia? Not x negative y, no. X negative y is reflection over the x-axis.
Oh,
This is the line y equals x. Not negate both, no. You switch both of them. So it's going to be y comma x. So you just switch their coordinates. So if I were you, I'd list out all the coordinates. And then perform the rule and mark it.
Bless you.
All right, so let's list out these coordinates. We have A, which is the point 1, 2, 3, 4, 5, 6, 7, 8, negative 8. And then 1, 2, 3, 4, 5. Oops, sorry, not negative 8, negative 7. Sorry about that. Negative 7, negative 5. All right, now let's talk about B. For B, we are negative 9, positive 1. For C, we are negative 4, positive 4. For D, we are negative 5, positive 7. And for point E, we are 1, 2, positive 3, positive 7. And the rule for reflection over the line y equals x tells us just switch your x and y coordinates. So what does that mean for us? That means our A prime will be negative 5, negative 7. So here's my A prime. My B prime will be 1, negative 9. Our C prime will be 4, negative 4. Our D prime will be 7, negative 5. And lastly, our E prime will be 7, 3. All right, and then we connect. Huh, did something go wrong here? RC.
No.
It looks right after you connect.
It looks right after we connected because it seems a little off right now. Okay. You're right. It does look right. And this is a reflection over the line. Oops. Y equals X. Maybe I'll start at the origin. Let me show you that line. Oops. Try this one more time. All right, so it's a reflection off of that line. Isn't that look like a perfect reflection over the line? All right, so we are done. Your homework